Alright guys, please take out your notes packet and your green sheet because we are going to go through both of those at the same time, so you're going to follow along. We already filled in this last class, and so we're going to do an example here. We did start talking about the opening up or down, so we're looking at this equation right here. And remember, we can look at this equation, and if it's in standard form, which it is, technically this would be x squared, 1x squared plus 0x minus 4, right? So this is my a value, this is my b value, this is my c value, okay? So we can know if the quadratic equation, if the graph will open up or down. If we look at the a value, that's what I wrote here, it's going to go up if a is positive, and it's going to go down if a is negative. So make sure you pause and write that in. So in this case, in this example, a is positive 1, so it will be opening up. So we know that our quadratic is going to look something like that. Okay, the x-intercepts. So the x-intercepts are always going to be an ordered pair that look like that. Some number, comma, 0. And we find the x-intercepts by solving the quadratic equation. So, and we solve the quadratic equation by setting it equal to 0. So I wrote, as you can see, it's the solutions to the quadratic equation when y equals 0. And what I mean by y is a lot of times we're going to have written f of x. So for example here, I would like you to take f of x, change it into 0, rewrite, and then solve. So in this case, we'd probably factor, then solve. And then just a quick reminder, 3 ways to solve: zero product property, factoring, right, square root method, or quadratic formula. So you might need to pause and make sure you have all that written down. Let's try our example over here now. So we need to solve this with a different color. So I'm going to say 0 is equal to x minus 4, or actually, if you don't mind, I'm going to put x minus 4 is equal to, or x squared minus 4 is equal to 0. And you could do two things. You can solve this by square root. You can solve it by zero product property, which is factoring. I think most of you would probably do square root method. So you would add 4, x squared is equal to 4, square root, x is equal to plus or minus 2. So how many solutions do we technically have here? We have 2 and negative 2. So because those are our two solutions, those are our two x-intercepts. We're going to write them separately, 2, 0, and negative 2, 0. Okay, and if we go to graph this down here, 2, 0 would be right here, and negative 2, 0 would be right here. All right, so now we're moving on to the y-intercept. The definition of the y-intercept is where the graph crosses the y-axis. So this is the solution when we set x equal to 0 and we solve for y. So I'm going to make that bigger so you can copy that in. You might need to pause and write that in. So the y-intercept happens when x is 0. So we're going to plug 0 in for x and solve. So if we do that, for example, I don't know, if we look up here at this one, we would plug 0 in for x, so you'd get 2 times 0 minus 1 times 0 plus 3. So we'd have 2 times negative 1 times 3, and that's negative 6, right? So that right there would be our y-intercept. One sec. So that's what would happen. That's how you'd find your y-intercept. And we could do that here too, right? So we could plug 0 in here, 0 squared minus 4, so I'm just plugging 0 in for x, and you would get 0 minus 4, which is negative 4. There's a shortcut, though. The shortcut is, as long as this is in standard form, which I said it is, your y-intercept is always going to be c, or the constant. So if this is in standard form, aka not factored, like this one, okay, if it looks like this, or if it looks like this is in standard form, our y-intercept is always going to be the constant, okay, the number without any variables next to it. So in this case, it is negative 4, so our y-intercept is 0, negative 4. And that's what I wrote here. Your y-intercept is always going to be an ordered pair starting with 0. So if we graph this, 0, negative 4, 1, 2, 3, negative 4, 1, 2, 3, right here. Okay. Now, our axis of symmetry. Remember, our axis of symmetry is not actually part of the graph. It's just like the mirror. And you can calculate the axis of symmetry. This you kind of just have to memorize. The axis of symmetry is a line. It's going to start with x equals. So when it's a line, and you calculate it doing negative b over 2a. Okay? So the b, pause this to write it down. The b comes from this, and the a comes from this. And where do they get this? Well, it all comes from the quadratic equation. What's the quadratic equation? Opposite of b plus or minus square root b squared minus 4ac all over 2a. Well, do you notice this right here? So this is kind of where they get this from. Something just to keep in mind there. But that's what we're going to do to calculate. So when we go to calculate the axis of symmetry here, so we can draw in our mirror, opposite of b over 2a. Now remember, what's our b value? The b value is what's in front of the x. Is there even an x term in here? No, there's not. So what's technically in front of it? 0. So our axis of symmetry is, like I said, opposite of b over 2a is equal to opposite of 0 over 2 times, and what's our a value? 1. And so that's 0 over 2, which is 0. So our axis of symmetry is x equals 0. And that's a line. Remember, like I said, it's not actually part of the graph. We're just going to draw it in with like a highlighter or a dotted line. Draw it right here at x equals 0, because that's going to be our mirror. Okay, our vertex is an ordered pair. It's always going to be an ordered pair. You get the x value. It's the same as the axis of symmetry, opposite of b over 2a. So once you already find the axis of symmetry, you have your x value. Then to find the y value, you're going to plug x into the equation to get y. So, for example, over here, your vertex, like I said, has the same x value as the axis of symmetry, so 0. And when I plug 0 in, 0 squared minus 4, so 0 minus 4, I get negative 4, right? So I'm actually going to change the color. Use that. Okay. So 0, and then when I plugged 0 in, I got negative 4. And this actually turns out to be the same as the y-intercept, which is okay. That sometimes might happen. All right. Now, one quick thing. The vertex is going to be your maximum or your minimum. If your parabola is pointing down, the vertex is here, it's a maximum. If your parabola is pointing up, your vertex is here, and that's a minimum. Okay? So just something to keep in mind. All right? Now, another point. The reason I put that is, you need 5 points to draw the graph. So look here, I only have 3, right? So it's going to look like a kind of V. It's going to look a little pointy. So we need 5 points to really round this out. There's 2 ways you can get some more points. One is you're going to reflect the y-intercept over the axis of symmetry. That's only going to work sometimes. It's not going to work in this example because where's the y-intercept? It's already on the axis of symmetry. So it's going to be hard to, we can't reflect it, right? So we have to go with option 2. We just got to pick some more points near the vertex to plug in a table. All right, so here we have to pick some more points. So we have a point here at x equals negative 2. We have one here at x equals 2. We have one here where x is 0. So I might just pick like a point if x is, like, for example, 1. So I can put a point somewhere around here. So if I pick the point 1 for x, I'm going to plug that in. 1 squared minus 4, 1 minus 4, negative 3, right? So 1, negative 3. So I'm going to plot that. 1, negative 3 goes right here. Now here's what's nice about that. Could I now make another table, plug in negative 1? Sure, right? What would you get? You would get negative 3. Without plugging it in, could you have done this? Right. You could have plotted this point because you can just reflect this point over the axis of symmetry. If it's 1 away from the axis of symmetry, you're going to reflect it 1 away over here. All right? So you could do that as well. So once you have 1 point, you could just reflect it. Now we have enough points to draw in our nice smooth curve. And there is our parabola. Here, I'm going to change that color. It's a little easier to see. All right. Cool. That's our parabola. Now, the domain. The domain is all the x values. So for this parabola, this one goes on forever and ever, right? And goes on forever and ever. So the domain starts here at negative infinity, and it goes on and on and on and on and on forever until positive infinity, right? So this is going to be from negative infinity to positive infinity. And I will tell you something. For all parabolas, it's always going to be negative infinity to positive infinity. So I would write that down. Our range. So our range is all of our y values. Well, so our y values seem to start right here and go up forever. So they start at -4 and they go up to positive infinity. So in this case, they start at -4 bracket and go up to positive infinity. That's pretty much always going to happen if we are working with a parabola that's going up. Your domain, or your range is going to start at the vertex, the y value of the vertex, because we're talking about range, right? So this is the y value of the vertex to infinity. But if it's pointing down, where's that range going to start? It's going to start down here at negative infinity and then just stop at the vertex. So if it's pointing down, your range is going to be from negative infinity to vertex. So make sure, I'll close this up. Make sure you have pause. Make sure you have all this written down because we're going to use it for the next example.